So in the last class, we have already seen what is P and C, permutation, combination. In a permutation, order matters. Okay, in combination, order does not matter. So all these points we have already seen. And we were discussing why 0 factorial is 1. This is what we were discussing. So I told you that if anyone asks you why 0 factorial is 1, then the answer is by convention. So this is the answer. You can check it. For example, here, like in this is a university slide. So here you can check. Okay, recall by convention 0 factorial is 1. Okay, so basically this is the convention that 0 factorial is taken as 1, or I can say this is the definition. By definition 0 factorial is 1. But why this convention? Like, okay, why these mathematicians, why they took this convention, why they took 0 factorial as 1? So the reason behind this convention, there are many reasons. Okay, like this is one of the reasons. You can notice number of subset of size r of a set of size n. So this is basically NCR. You know, from n elements you want to select r elements. Okay, because in a subset only selection matters, order does not matter. So here order does not matter. Here the order does not matter in a subset. The order of elements does not matter. So basically the only thing that matters is what are the elements you are selecting. So from n elements you are selecting r elements. So n choose r. From n you are choosing r elements. Now how many subsets of size 0? So the answer is 1. That is your 5. This is the subset of size 0. Correct. So only one subset of size 0 you have, that is 5. Okay, so what this becomes? This becomes NC0, and NC0 should be 1. Correct. So I can say that NC0 is 1. And you know what is NC0? That is n factorial divided by n minus 0 factorial 0 factorial. This should be equal to 1. Now already I can cancel them. Okay, so finally I can say from here, what can I say? I can say 0 factorial is what? So 0 factorial is 1. Okay, so this is one of the reasons. This is not a proof. Is this a proof? Can I say this is a proof? No, this is not a proof. This is not a proof. This is the reason, one of the reason behind this convention. Okay, so remember, this is not a proof. This is not a proof. This is not a proof of 0 factorial equal to 1. This is the reason behind this convention. One of the reasons. This is just one of the reasons behind this convention. Okay, one of the reasons behind convention. One of the reason behind convention 0 factorial equal to 1. Okay, so don't say that this is a proof. This is basically one of the reason I can say. Like for example, tell me how many subsets of size n plus 1 from a set of size n. How many subset you can create of size n plus 1? How many subset you can create? Number of subset that you can create. Okay, so only 0. No subset you can create. So number of subset of size n plus 1. So that should be what? That should be nc n plus 1. So this is equal to 0. So this is equal to 0. Okay, so nc n plus 1, that is nothing but 0. Okay, next, tell me number of subsets. How many subset you can create of size r, that is greater than n, of a set of size n? How many subsets you can create? Tell me, of size r, and r is greater than n. So how many subsets you can create? Okay, so that also will be 0. You cannot create any subset of size r which is greater than n from a set of size n. So from here I can say NCR, when r is greater than n, that should be equal to what? NCR, because this is the number of subsets. Remember, this is the number of, remember this is the number of subset. This is the number of subsets of size r, from n elements, Okay, so this is the idea. So I can say that when r is greater than n, then I can say NCR is equal to 0. Okay, so this is the idea. So you can notice why we define that, why this is how we define. This is a definition. Why we define this 0 factorial equal to 1. So that is, the idea is very simple. If you have this set, then how many ways to select 2 elements? So these 2 people you have 2 people. So from these 2 people, how many ways to select 2 people? From 2 people, how many ways to select 2 people? Only one way. You have to select both of them. Okay, so there is one way. How many ways to select one person? There are two ways. Either you can select this or you can select this. How many ways to select none of them? How many ways to select none of them? Only one way. Don't select anyone. How many ways to select none of them? None of them. Okay, so only one way. Don't select anyone. Only one way. Now tell me, how many ways to select three of them? How many ways to select three of them? How many ways to select three of them? Zero way. Zero way. You cannot select. You cannot select. It is not possible. It is not possible. See, if you want to select none of them you want to select. Like there are two person and you don't want to select any of them. Then there is one way, right? You can do that. Can you do that? Like there are two people. You don't want to select any of them. Can you do that? Yes, we can do. Okay. Yes, we can do. There is one way. Okay. Yes, we can do. Okay. So there is one way. If you don't want to select any of them, but there are two people. Can you select three of them? There are two people. Can you select three of them? There is no way. There is no way. Impossible. Okay. So that is the reason. Okay. This is zero way. Now let's move on. So tell me, selecting n people from n people, selecting n people from n people, what should be the answer? Tell me, selecting n people from n people, selecting n people, you want to select n people from n people, what should be the answer? If you want to select n people from n people, then answer should be one. Only one way. Okay, selecting n people from n people, there should be only one way. Selecting zero people from n people, like, okay, if you want to select zero people from n people, then there is only one way, that is nc0. So nc0 is equal to 1. Now selecting zero people from zero people, selecting zero people from zero people, if you want to select zero people from zero people, then what that will be? That will be 0c0. That is also one way. Like there is no one in a room, in a room there is no one, and you are selecting none of them. Okay, so there is one way, right? Okay, there is a one way. So anyway, selecting zero people from zero people, that will be 0c0, and that is also one. From this set, if you want to make a subset of size 3, then it is not possible. So I can say how many subsets of size 3? That will be 0. 0c0. This is 1. Why this is 1? It's like this. Just consider that there is an empty room. Let's assume there is an empty room. In this room there is no one. Okay, and you are selecting none of them. In this room there is no one, and you want to select none of them. You want to select none of them. So how many can you do this? See, in this room there is no one, and you want to select none of them. Can you do this? Yes, it is possible. There is one way. So remember this. So NCR, this NCR, okay, this is called binomial coefficient. Why this is called binomial coefficient? I will tell you after some time. When we study binomial theorem, I will tell you this NCR. This is called binomial coefficient. This is known as binomial coefficient. Okay, this is the name of NCR. So this NCR we call it binomial coefficient. Next, one thing more. This NCR, how will you think it logically? See, this NCR you can think like this: n factorial divided by n minus r factorial, r factorial. This is algebraic. This is algebraic. Okay, this is algebraic meaning. Yes or no? This is the algebraic meaning. This is the algebraic meaning. This is boring. This is boring. What is the combinatorial meaning? What is the combinatorial meaning? Like, give me some combinatorial meaning. Combinatorial meaning. What is combinatorial meaning for this NCR? This is selecting R people from N people. This is selecting R people, selecting R people from N people. Okay, so you are selecting R people from N people. So this is the combinatorial meaning. Okay, clear? So quite simple this is. So remember, this is algebraic meaning and this is a combinatorial meaning. And this combinatorial meaning will help you many times. So you are selecting R people from N people. Let's move on. Now, let's see some standard questions and templates in permutation combination. All the standard variations we will do, every standard variation we will do. Okay, so let's see this question. This is the first type of variation. So there are n faculty members in mathematics department, 11 faculty member in computer science department. How many ways are there to select a committee to develop a discrete mathematics course? If the committee should consist, okay, so this question is given to you. So there are nine faculty in mathematics, 9 faculty in mathematics department, 11 faculty in computer science department, and you want to select, the question is asking how many ways are there to select a committee. You want to select a committee such that there should be 3 members from mathematics and there should be 4 members from computer science. So you can notice that there are 9 maths department, 9 maths faculty you have, and 11 computer science faculty you have. And what you want to do, you want to select 3 of them, you want to select 3 of them, and you want to select 4 of them, you want to select 4 of them. So you want to select 3 of them, and you want, this is and. So how many ways to select 3 of them? 3 maths faculty you can select in 9C 3 ways, and because of this and, I can say this multiplication will come, and then 11C 4, select 4. So this will be your answer, 9C3 11C4. Okay, this same answer you can also write like this, because you know that this answer I can also write like this, correct? We already know that NCR is equal to NCN minus R. NCR, okay, this NCR, this is equal to NCN minus R. So this answer you can write in many different ways you can write. So 9C6 multiplied by 11C7 also you can write. All these things are same. Okay. So this is the idea. Okay, next. So tell me, what is the answer for this? Mr. Smith is chair of committee. How many ways can a committee of 4, you want to create a committee of 4 elements? How many ways a committee of 4 can be chosen from 9 people, given that Mr. Smith is already selected? Okay, so remember, Mr. Smith is already selected. Okay, you want to remember, from 9 people, you want to select 4 people, but Mr. Smith is already there. But Mr. Smith, okay, Mr. Smith is already selected. So if Mr. Smith is already selected, then it means from 8 we need to select 3. It means from the remaining 8 we need to select 3. So what will be the answer? Answer will be 8C3. And how to find this 8C3? I told you this is 3 terms, 8 into 7 into 6, 3 terms divided by 3 factorial. So this is your answer, because Mr. Smith is already selected. Let's see this question. What is the answer? A certain password consists 3 different letters. There are 3 different letters, and each letter is used only once. So if this password has 3 letters, different letters, each letter is used only once. How many different ways this password can be created? So basically from 26, you want to select or you want to permute? You want to select or you want to permute? Order matters. In a password, order matters. So in a password, order will matter. So what you want to do? You want to permute 3. So this answer you can get. Okay, or you can apply the product rule. So there are 26 choices, 25 choices, and 24 choices. You can multiply. This is product rule. Or you can bring it down. So you can start from 26 and there will be 3 terms. There will be 3 terms. So this is your answer. Okay, next. What is the answer for this? A password consists of 3 letters followed by 3 digits. 3 letters followed by 3 digits chosen from 0 to 9. Repeats are allowed. Repeats are allowed. Now, what is the answer? Repeats are allowed. How many different ways? So here you can apply the product rule. Just apply the product rule. Remember, permutation combination is also nothing but your product rule. So you can apply the product rule here. So 3 letters means 26, 26, 26, and 3 digits means 10, 10, 10. So the answer will be this. Your answer will be 26 power 3 multiplied by 10 to the power 3. So this will be your answer. Okay. Can you apply permutation here? Can you apply permutation like NPR? NPR. Can you apply permutation NPR? That we cannot do here. NPR, because here repetition is allowed. So basically here what you can do, you can have this type of thing. You can have this type of thing you can have. Okay, this type of thing you can have. So this is the idea. Okay, because repetition is allowed. Remember permutation, when you can apply this NPR formula, when can you apply? When can you apply this NPR? This formula, when it is applied, this is applied, this formula is applied when you have n distinct people from n distinct, you have n distinct things and distinct elements you have, and from them you want to select r distinct elements. From them you want to select r distinct elements. So without repetition, repetition should not be there. From n different people you want to select, from n different people you want to select r different people. Then in this situation you can apply this NPR. Okay, and you want this P means permute. This P means permute, means order matters, means ordered arrangement. So this is the idea. Encyclopedia has 6 volumes. In how many ways can 6 volumes be placed on a shelf? So that is your 6 factorial. Okay, very simple. The idea answer will be 6 factorial. Next, this is another question. This type of questions they can ask you. They will give you some definition and then they will ask you how many. For example, you know what is a poker hand? I told you. Poker hand is basically that consists 5 cards. Okay, so a poker hand consists of a 5 cards, 5 randomly chosen cards out of a deck of 52 cards. Okay, so this is your poker hand. This is the definition of poker hand. So a poker hand, it contains 5 cards. Okay, don't worry, in the GATE exam they will give you what is the definition of poker hand. So poker hand is basically 5 cards. Okay, and what is the definition of full house? So have you played poker? This game have you played poker? In this game basically there is something called full house and there are some other things. Okay, so don't worry. So basically like maybe you have watched some movie. Have you seen some movie that there are 5 cards? Okay, so you have full house and there are some hierarchy. There is a hierarchy here. I think there is full house and there are some other things are also there. Okay, so anyway, so let's forget about it. What is the definition of full house? This is the definition. A hand consists of 3 cards of same value and 2 cards of another value. This is called full house. Is this clear? The definition of full house, is this clear? So you have 3 cards of same value and 2 cards of different value. You have 3 cards of same value and 2 cards of different value, like 3 cards of same value, 2 cards of different value, like 3 kings and 2 eights. So this type of thing is called a full house. So in a full house we must have only 2 values must be there. In a full house you must have 2 values. So okay, so this is the idea. In a full house what should happen? In a full house, this is a poker hand. This is a special type of poker hand. In this you must have 2 different values. You must have 2 different values. Exactly 2 different values you must have, A comma B. Then for this A you must have 3 cards. You must have 3 cards of A and you must have 2 cards of B. This is called full house. Is this clear to everyone? Now tell me how many full house you can create. How many full houses are possible? So the question is asking how many full houses are possible. So if you want to create a full house, what do you need? If you want to create a full house, first what you need? So method 1. So first you decide who is going to be the 3 values. like the three values. Who will be the three values? See, who will be the three cards? Means three cards of a value, so who will be that card? So that card can be from 13 values. You can select one value, correct? Yes or no? Okay, from 13 values, there are 13 values. From that you can select one value. Okay, after selecting one value, like for example, let me select 5. After selecting one value, I should select 3 suits. I should select 3 suits. So from 4 suit, I should select 3 suits. Okay. Now, this is a 2 cards of another value. This is 2 cards of another value. Here what we will do? 2 cards of another value. So from 12 values, I can select one value. From the remaining 12 values, I can select one value. And now from 4, I can select 2 suits. From 4, I can select 2 suits. Is this clear? Tell me, is this point clear to everyone? So basically, I'm finding, okay, who is the card with 3 values? Who is the card with 3 values? This is to select a suit. Let's assume you are selecting, say, okay, just first, okay, this is how to create full house. This is the complete thing to create full house. First, you select one value. Full house is basically 3, 2. So for full house, what you do? First, you select a card which will repeat 3 times. Select a value which has 3 cards. Which has 3 cards. Okay. So select a value which has 3 cards. How many ways? Select a value which has 3 cards. How many ways? Tell me. Select a value which has 3 cards. Select a value which has 3 cards. So 13C1. In a cards game, how many values are there? In a cards game, there are 4 suits. There are 4 suits or types, and each suit has 13 values. There are 13 values of each suit. So total you have 52 cards. So total there will be 52 cards. Is this clear? You have only 13 values you have. Only 13 values you have from 2, 3, 4 and so on 10, then jack, then queen, then king, then ace. These are the 13 values. And there are 4 suits. Each value has 4 suits. Each value has 4 suits. Okay, 2 of diamond, 2 of heart, 2 of diamond, 2 of this, something like this, and 2 of, okay, what is that? Another symbol, 2 of something, okay, whatever. So like this. So this is the idea. Is this clear? So there are 4 suits and only 13 values you have from 2 to 8. So finally, what is a full house? If you want to create a full house, first you select a value which will have 3 cards. First you select a value. For example, this value 5, this has 3 cards. Yes or no? This value 5 has 3 cards. This value 4 has 2 cards. So first you select a value which have 3 cards. So 13C1. Now for this value, whichever value you select, for this value, what we need? We need 3 suits. For this value, need 3 suits. For this value, whatever value you choose, for this value, we need how many? We need 3 suits. Is this clear? For this value, we need 3 suits. Like if you select this value 5, then we need 3 suits. So there are 4 suits. From that, you need to select 3 suits. And finally, okay, so this is one card. And what you do? Now select a card, select a value which has 2 cards. Select a value which has 2 cards. Which has 2 cards. So select a value, select another value which has 2 cards. So how many ways? 12C1. Already one value we have selected. Select another value which has 2 cards. So 12C1. Now for this value, for example, if you select this value 4, then you need 2 cards. Now for this value, we need 2 cards. For this value, we need 2 suits. 2 suits you need. So finally, what that will be? That will be 4C2. Is this clear? Full house. How to create full house? Okay, tell me one by one. What you will do? If you want to get a full house, what you will do? First, you will select a value. So let me select value 7. Let me select value 7. For this value, so let me select a value which has 3 cards. Let me select a value which has 3 cards. Value with 3 cards. Value with 3 cards. So let me select this value. Once I select this value, now I need 3 cards. I need 3 cards. So I will have to select 3 suits. I will have to select 3 suits. Is this clear? Tell me. So first you select a value with 3 cards. So this value I am selecting. First you select a value with 3 cards. So 13C1. 13C1. There are 13 values. From that you are selecting one value. Okay. There are total 13 values. From them you are selecting one value. So let's assume you select this value. Now after selecting this value, you need to select from 4 suits. You need to select 3 suits. Okay. Now what you do? Also what you need to do? Value with 2 cards. Another value. There should be another value with 2 cards. So what will you do? Another value with 2 cards. So let me select queen. Another value with 2 cards. So there are 12C1 ways. From 12 remaining values, there are 12 remaining values. From 12 remaining values, I am selecting one value, queen. Once I select this, I need to select 2 suits. So queen of heart and queen of, like this. Is this clear? Tell me. So after selecting this value, what I need to select? From 4 suits, I need to select 2 suits for queen. Is there any doubt? This is the definition of full house. You should have 2 different values, a comma b. You should have 2 different values. You should have a comma b. This is the definition of full house. So you must have 2 different values. One value will have 3 cards, another value will have 2 cards. Okay. So another way, there is another way to answer this. There is another way. What is that? First you select from 13, you select 2. Okay, there is method 2. Let me tell you the method number 2. Understand this also. So this is your method number 1. Method number 1. Now let me give you method number 2. What is method number 2? Directly select 2 values. Directly select 2 values. From 13, you directly select 2 values. From 13, you select 2 values. Let us assume you select 4 comma king. Let us assume you select 4 comma king. Let us assume. So from 13, you directly select 2 values. So you are, let's assume you are selecting 4 comma king. Now what you need to do? Now what we need to do? Tell me, please tell me. Now what we need to do? We need to decide who will have 3 cards. From these 2, who will have 3 cards? Now from these 2, we have to decide. We have to select 1 for 3 cards. We have to select 1 for 3 cards. Okay, which one will have 3 cards? So let us assume this 4 one will have 3 cards. Okay, means from these 2, I will decide. From these 2, I will decide. From these 2, I will decide who will have 3 cards. So from these 2, if I want to decide who will have 3 cards, then 2C1. For example, 4 can have 3 cards. Now this 4 has 2 cards. So from 4 suits, I will select 3 suits for, okay, and from 4 suits, I will select 2 suits for this king. Is this clear? What I'm saying? I'm saying from 13, you select 2 values. Now you decide who will have 3 cards. Now you decide who will have 3 cards. Let us assume 4 will have 3 cards. So this is for 4 and this is for king. This is your another answer. Is this clear? Next, what is the answer for this? How many bit strings of length n contain exactly R1s? How many bit strings of length n contain exactly R1s? So you have a bit string of length n and that contain exactly R1s. So this is your bit strings. This is your, for example, you have bit string of length, let's assume length 4, which contain exactly 2 ones. Now you have bit string of length 4 and it should contain exactly 2 ones. It should contain exactly 2 ones. There are 4 positions. There are 4 positions. From these 4 positions, what you can do? For there are 4 positions. From these positions, you select 2 positions for one. For ones, you select 2 positions. So let us assume, let me select this position and this position. So these 2 positions you select for 1. Automatically in the remaining positions, who will go? Automatically in the remaining positions, who will go? 0. Automatically in the remaining positions, 0 will go. So your answer is 4C2. So basically from 4 positions, you select 2 positions and you put 1 there. You put 1 there. Automatically in the remaining position, 0 will go. So this is your answer. So answer will be what? That will be NCR. For this question, you have total n positions, and from these n positions, you select R positions. Select R positions for 1. Okay, so from n positions, you are selecting R position for ones. The remaining position automatically they will be filled by 0. Let's see this question. What is the answer for? Exactly 3 zeros. What will be the answer? Exactly 3 zeros. Means from 10 positions, you select 3 positions for zeros. So there are 10 positions. You select 3 positions for zeros. The remaining positions will contain 1. Automatically, the remaining positions will have 1. More zeros than ones. What we need to do here? When you read this question, what will come to your mind? More zeros than ones. Then your mind will come by case. Yes or no? More zeros than 1. Then in your mind, it will come by case. So more zeros than 1. You should have more zeros than 1. Okay, and the length is 10. The length is 10. So the cases, you can create cases. More 0, there should be more 0. Maybe there are 10 zeros. Okay, maybe there are 10 zeros. So maybe there are 10 zeros. So automatically there will be 0 ones. Or so either this you will have, or what you can have, 9,1 or 8,2 or 7,3 or 6,4. That's it. Only these cases are possible. Yes or no? Okay, so finally 10 zeros, exactly 10 zeros, and there is only one way. There is only one way. Just put all the zeros. All the things should be zeros. Here what you should have? 9, exactly 9 zeros and 1 1. So I can say 10C9 or 10C1, whatever. 10C1 or 10C9, both are same. Both are same. And what here? There should be more zeros than ones. What should be here? So 10C2. This should be 10C3. And this should be 10C4. So what will be the answer? So your answer will be what? 10C. So this one I can say, okay, so I can say maybe 10C10 plus 10C9 plus 10C8 plus 10C7 and plus 10C6. This is your answer. This is your answer. Another answer is 10C0, 10C1, 10C2, 10C3, 10C4. This is another answer. Both are correct. Okay. So basically here I am saying that these are the 9 zeros and this is 1 1. Here 8 zeros, 2 ones, 7 zeros 3 ones, 6 zeros, 4 ones. Is this clear? Is this question clear to everyone? So just more zeros than ones. So you can create cases, and very simple. Next, at least 7 ones. What should be the answer? At least 7 ones. There should be at least 7 ones. There should be at least 7 ones. What should be the answer? So let's check it out. At least 7 ones you want to create. So from 10 positions, let me select 7 positions for ones. For ones, let me select, yes or no? From 10 position, let me select 7 positions for ones. And in the remaining positions, anything can come. In the remaining 3 positions, anything can come. Is this a correct answer? Is this answer correct? For ones, okay, and okay, anything means 1 comma zeros, 1 ones comma zeros. So is this answer correct? Let me tell you, this is wrong answer. And let me tell you, this is the biggest mistake that students make. This is the most common mistake. This is the most common mistake. Remember, this is most common mistake. If anyone asks you what is the most common mistake in combinatorics, you can say that this is the most common mistake. What is the mistake here? Can anyone tell me what is the mistake here in this question? In this question, what is the mistake here? Let me show you the mistake here. You have done overcounting. You have done overcounting. This is not undercounting. This is overcounting. Okay, so let me take with example. Let me just explain this. So here this is wrong, and why this is wrong? So let me explain. So let's assume that you have, length 4. Let's assume you want length 4 and at least 2 ones. At least 2 ones you want. Okay, and let's assume you apply this. So tell me, length 4, at least 2 ones you want. So what should be the actual answer? The actual answer, what should be that? Length 4, at least 2 ones should be there. At least 2 ones should be there. So what should be the actual answer? Okay, or maybe I can say 3 ones. Okay, so it will save us some time, because I just want to explain. So at least 3 ones. So what is the actual answer? There should be at least 3 ones. So either you can have this, or 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 you can have this. Okay, so the actual answer is what? Okay, so that is 5. Actual answer is 5. Now if you do like this, that first you select from 4, you select 3 4 ones. You select 3 4 1. 3 positions you are selecting for ones, and in the remaining position anything can come. In the remaining position anything can come. What is this? What is this answer? This is 8. So can you notice there is overcounting? You are overcounting. Yes or no? This is wrong. This 8, this is definitely wrong. But how did you do overcounting? See, let me tell you, where did you do overcounting? See, you are considering ones here. This is reserved for 1. Can I say this is reserved for 1? These positions, can I say they are reserved for 1? Yes, these positions are reserved for 1. And you are allowing anything here. So can I say 1? Okay, these positions are reserved for 1. Can I say here also 1 is allowed? Can I say here also 1 is allowed? Can I say 1 is allowed? Yes, you are again allowed. Okay, again 1 is allowed. Again 1 is allowed. Again 1 is allowed. So okay, these positions are reserved for ones, and again you are allowing ones. And this is the problem. Let me tell you how the problem will happen. How the overcounting will happen. You are selecting 3 positions. So can I select first, second, third? Okay, you are selecting 3 positions. So can I select first, second, third? From 4, you are selecting 3 positions, 4 ones, reserved for ones, and in the remaining position anything. So when you are selecting 3 positions for ones, then can I select these positions? Because you are selecting 3 positions, so can I select first comma, second comma, 3 position, these positions for 1? Can I do this? Yes. Okay, and then we are allowing anything, and the remaining position anything can come. In the remaining position, can I allow 1? In the remaining position, what I can do, in the remaining position I can allow 1. This is possible, correct? From your answer this is possible, because you are selecting 3 positions for 1, you are selecting 3 positions for 1, and the remaining position can have 0 or 1. So this is one possibility. This is one possibility. So what answer you will get with this situation, with this selection? What answer you will get? You will get, okay, these positions will have 1 1 1. See, these positions will have 1 1 1 reserved for 1, and this position will have 1 because the remaining position has 1. Now the same answer, this same answer you will get in 3 different ways from this. How will you get? See, if you are selecting 3 positions, can you select 1 to 4? Can you select 1 to 4 position for 1? You are selecting 3 positions, right? Yes or no? You are selecting 3 positions for 1. Can you select 1 to 4 position for 1? Yes. Okay. And the remaining position anything can go. The remaining position anything can go. So let me allow 1. The remaining position anything can go. So 1 also can go. So I am selecting these 3 positions. I am selecting for 1. This position, this position, this position. And in the remaining position, I am putting 1. Can you notice this same thing you have counted 2 times? Yes or no? This same thing you have counted 2 times. So here I can say this string has been counted how many times? This string has been counted how many times? Has been counted how many times? You can just check it. This string will be counted 1 2 3. So this string will be counted 4 times. This string has been counted 4 times. You can check. Because what other thing I can do? What other thing I can do? I can select 1 2, I can select 2 3 4. I can select these positions, and in the remaining position, so I can select these positions, I can select, and then you can notice that. And similarly I can select maybe 1 3 4. I can select 1 3 4. In this situation what will happen? So these are reserved for 1, and here 1 will go. So this string has been counted 4 times. Overcounting, you are doing overcounting. So is this clear to everyone why this answer is wrong? Why this is most common mistake? Because you are allowed, see, very simple. The very simple logic, let me tell you, these are reserved for ones. Can you notice these are reserved for ones? And you are again allowing ones here. See, these seats are reserved for ones, and again you are allowing ones here. So because of this situation, always overcounting will happen. Always overcounting will happen because of this situation. Means these are reserved for ones, you are reserving them for ones, and you are again allowing ones here. In the remaining positions, you are again allowing ones. So I can say that in this situation, always overcounting will happen. So this is the most common mistake, and we have done overcounting. We have done overcounting. Because you can notice from this example, you can notice same case you have counted 4 times. Every valid string has been counted, but you have counted same thing many times. This is a valid string you have counted 4 times. This is called overcounting. Every valid string you have counted. How many times this string should be counted? Tell me. This string should be counted 1 time. So answer will be 8 minus 4 plus 1. 3 extra, only 3 extra you have. 4 extra you don't have. 3 extra you have. Is this clear? This string you have counted 4 times. You should count it 1 time. So 3 extra. So the answer will be 8 minus 3. Answer will be 5. Okay, so I can say here, I can say that you have counted it 4 times, so I can say 3 extra. I can say 3 times 3 times is extra. 3 times is extra. 3 is extra. I can say. I can say 3 is extra. So remember this point always. I'm giving you this thing. This is very important note. Okay, always take care. Basically, you will, okay, this always don't ever do this. What you do? Okay, so let's assume you are doing this. That here, let's assume these are reserved for A's. Let's assume anytime, let's assume these are reserved for, these things are reserved for, let's assume type 1 people, type 1 people, type 1 people. Okay, so let's assume these things are reserved for type 1 people, type 1 people. Okay, there are type 1, type 2. Okay, so these things are reserved for type 1 people. Now if you allow, don't allow type 1 people in the remaining, don't allow type 1 people here, don't allow type 1 people here. Is this clear to everyone? So if you are reserving, if you are reserving these for type 1 people, here you have considered all the possibilities for type 1 people, you have considered everything for type 1 people, then don't allow type 1 people here. Don't do this. And what is the mistake? And what is the most common mistake? What is the most common mistake? The most common mistake in combinatorics, that is you are reserving these for type 1 people and you allowing these type 1 people. Okay, you are allowing okay, type 1 people here. So this is the idea. I hope this idea is clear to everyone. So are we clear that you understood this mistake? Did you understand this mistake? So let's talk little bit about this question. So you have four length, you have 4 length bit string. Let's see something more, because GATE exam is all about variations. Okay, let's discuss something more. You have 4 length bit string and you want at least 2 ones. You want at least 2 ones. Now we know that this answer is wrong. We know that from 4 position you select 2 position reserved for ones. These are reserved for ones. Okay, now in the remaining 2 position you can have anything. In the remaining position you can have anything. 0 you can have, 1 you can have. Okay, 0 you can have, 1 you can have. We know this is a wrong. We know, okay, no problem. We know this is wrong. We know this is wrong. This answer is wrong. But some interesting question. Okay, please focus here. Please focus on important thing. If you miss out these tricky things, if you miss out, then what is the benefit? Okay, focus on what is going on. I will answer this question. Don't worry. This question I will answer. But let's focus on this common mistake. First, let's understand all about this common mistake. Everything about this common mistake, let's understand. Okay, so about this common mistake, I am going to explain everything. So you can notice this is wrong, you know. But my question, interesting question, let me ask. You know that this thing is wrong. But here, how many times you counted this string? My question is, how many times? Okay, this is the interesting question. See, this thing is wrong. This is overcounting. Overcounting means every valid string you have counted. Every valid string you have counted. And have we counted any invalid string? Tell me. Did we count any invalid string? Did we count any invalid string? No. Remember this most common mistake. In this most common mistake, we do overcounting. We always do overcounting. Overcounting means, whenever I say overcounting means all the valid cases you have counted. Invalid case you did not count, but the valid case you have counted more than one time. Okay, what this overcounting means? Remember, whenever I say overcounting, this word whenever I use, then what I mean, it means all valid cases you counted. All valid cases counted. All valid cases you have counted. All valid cases you have counted. No invalid case you count. No invalid case counted. Then what is the problem? Then what is the problem? All valid cases you have counted. No invalid case you count. Then what is the problem? The problem is some valid cases you have counted more than one time. Some valid cases has been counted. Some valid cases counted more than one time. Counted more than one time. More than one time. Okay, so this is the meaning of overcounting. Overcounting, this has this meaning. Means you are counting some valid cases. You are counting more than one time. Invalid case, you are not counting. So in this common mistake, you always do overcounting. In this common mistake, always you will do overcounting in this common mistake, in this particular common mistake. Okay, so let's see here. This is interesting question. So tell me, how many times this string we have counted? 1001 counted. Tell me, how many times this string we have counted? How many times did we count this string? This string we have only counted one time. Yes, very good. How many times we are counting this string? This string we are only counting one time, once. See, just tell me. Okay, just tell me how. Okay, how can I create this string from this logic? How can I create this string? Tell me. From this logic, how can I create this string? First, I will select two position. First, I will reserve two position for ones. I will reserve for two position for ones. So these two positions are reserved for ones. In the remaining position, 0 is going. In the remaining position, 0 is going. Can I create this string in any other way? Can I create this string in any other way from this logic? No. So this string only we counted one time. Is this clear to everyone? This string we have counted only one time. Okay, let's see this string. Now let's talk about this string 1110. How many times we counted this string? How many times have we counted this string? This string we have counted 3 times. This string we have counted 3 times. How did we count 3 times? This string, how did we count 3 times? In first time, I am selecting these positions. In first time, I can select these positions reserved for ones. In second way, I can select these positions reserved for ones. And in another way, I can select these positions reserved for ones. Are you getting? Are you understanding what I'm saying? First, you are selecting in one way, you can select these two positions reserved for ones. Two positions reserved for ones. You can select these positions reserved for ones. In another way, in parallel universe, okay, you can select these two positions reserved for ones. In another parallel universe, you can select these two positions reserved for ones. Yes or no? This same string you can create. So these are the reserved for ones. These are the reserved for ones. These are the reserved for ones. Okay. Now in the remaining, you can put what you can do in the remaining. What you can do, you can put. So these are reserved for ones. And in the remaining, you can put 10. You can put 1 0. You can put 1 0. So there are 3 times you have counted this string. This string you have counted 3 times. Is it clear to everyone? Tell me. Is this point clear? So this string you have counted 3 times. I hope you are getting this. I hope you are understanding what I'm asking. How many times you have counted this string 1011? How many times this string has been counted? Again, this string has been counted 3 times. This string again I have counted 3 times. How many? Okay, how I am counting this 3 times? Because I can reserve this and this for ones. In parallel universe, I can reserve this and this for ones. In another parallel universe, I can reserve this and this for ones. So these I'm reserving for ones. These I'm reserving for ones. And in the remaining position, anything can come. In the remaining position, I will put 0, 1. Okay, in the remaining position, I will put like this. In the remaining position, I will put like this. So you can notice same string you have counted 3 times. So 2 times extra. Yes, very good, very good. So this string has been counted 2 times. So sorry, 3 times, but 2 times extra. For this string, 2 times extra. Okay, is this clear? I can say 3 times, so I can say 2 extra. And what about this string? Finally, okay, just one last variation. How many times this string we have counted? How many times we have counted this string? 0 times. This is invalid string. This is invalid. Okay, this string we have not counted. Because see, what is your logic? Just focus on your logic. What you are doing? Why I can say that this you have not counted? Can anyone tell me how can I say that this you have not counted? How can I say, how can I guarantee that this string I did not count? How can I guarantee that this string I did not count? Because I'm already reserving 2 positions for 1. I'm already reserving 2 positions for 1. I'm already reserving 2 positions for 1. So this string I have not counted. And this is invalid string I have not counted. And what about this string? 1, 1, 1. What about this string? How many times this string has been counted? So this string has been counted 6 times. This string has been counted 6 times. Total 6 times this string has been counted. Because from 4 position you can select 2 position. From 4 position you can reserve 2 position. From 4 position you can reserve these 2 position. 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 You can reserve these 2 position, and you can reserve these 2 position. So 6 times you have counted this string, 5 times extra. Is this clear? Is this clear to everyone? So these are the reserved position. These are reserved for ones. These are reserved for ones. These are reserved for ones. And in the remaining position, I can put like this. In the remaining position, I can put like this. So this same string you have counted 6 times. Is this clear? How 6? From where I'm getting this answer 6? Because 4C2. Because 4C2. So 6 times you have counted 4C2. I hope this question is clear to everyone, what I'm asking. Now, this question, this is a new type of variation. I hope in the GATE exam, they ask this question sometime. So let us assume that this is our question. So you have n length bit string. This is the final conclusion I want to give. Let's assume you have n length bit string. I'm talking about n length bit string containing at least r. Okay, so containing, for example, let's do this. Let's assume you have 10 length bit string and containing at least 6 ones. At least 6 ones. Now you quickly tell me, if I do this, okay, one student does this. One student who does this answer, who does this calculation. So he does this. From 10, you select 6 reserved for ones. Reserved for ones. And the remaining position, they can have anything. The remaining 4 position, the remaining 4 position can have anything. Means they can have 0, they can have 1, they can have anything. So this student does this. One student does this. Okay, so this student, okay, so let's call this student Y. So this student does this. Now tell me, Y has counted this string how many times? 1 1 1 1 1 1 6 1 1 0 0. How many times this string has been counted by Y? Y has counted this string how many times? Remember, there should be 6 ones. 6 ones are reserved for 6 positions are reserved for 1. these 6 positions are reserved for 1. The remaining position can have anything. So how many times this string has been counted? So this string you can count in 8C6 ways, because you have total 8 ones. You have total 8 ones. You have total 8 ones. So from these 8 ones, you can select 6 which are reserved. Yes or no? Yes or no? Agree or not? See why? Why 8C6? Why 8C6? Because there are 8 ones. You have total 8 ones. So from these 8 ones, you can decide which 6 are reserved. From these 8 ones, from 8 ones, decide which 6 are reserved seats. Which 6 are reserved seats for ones. Okay, are you understanding this logic? Because there are total 8 seats, there are total 8 ones. From that you decide which 6 are reserved seats for ones, which are the reserved seat for ones. So there are 8 seats. Remember, this has been counted 8C6 times. This string has been counted 8C6 times. And what about this string? How many times this string has been counted? So how many times this string has been counted? Only one time. 6C6 means only one time. This string has been only counted one time. And how many times this string has been counted? 5. 1, 2, 3, 4, 5. How many times this string has been counted? This string has been counted 10C6 times. So this is the complete analysis. This is the complete analysis of this common mistake. So now, can you ever forget about this common mistake? But just tell me, this is the complete analysis of this common mistake. This is the complete analysis of this common mistake. I hope you will never forget about this. This common mistake, I think you will never forget about this. So this mistake you will never not do, I hope. Okay. So anyway, now how to solve this? So this question number C, at least length 10. So you want length 10 and at least 7 ones must be there. At least 7 ones must be there. So you can create cases. This you can very easily create cases. So what is the, by cases you can create at least 7 ones, means I can say exactly 7 ones, or exactly 8 ones, or exactly 9 ones, or exactly 10 ones, or exactly 10 ones. Okay, remember, I can say exactly, I can say exactly 7 ones. Either you can have exactly 7 ones, or you can have exactly 8 ones, or you can have exactly 9 ones, or you can have 10 ones. Okay, so exactly 7 ones, that is 10C7. Exactly 8 ones, that is 10C8. Exactly 9 ones, that is 10C9. Exactly 10 ones, that is 10C10. This will be your answer. Is this clear? Is this clear to everyone? Are they disjoint? Exactly 8 ones, exactly 9 ones, are they disjoint? Yes, they are disjoint. Here you have exactly 8 ones, here you have exactly 9 ones. So yes, they are disjoint. What is the question number D? The question number D is at least 3 ones. Now what to do? At least 3 ones. Now you can do the complement thing. Now you can do the complement thing. See, one solution is like this. One solution is at least 3 ones. So exactly 3 ones, exactly 4 ones, exactly 5 ones, exactly 6 ones, and so on, exactly 10 ones. This is one solution. This is a one solution. And what is another solution? What is the another solution? The another solution is from total you remove when you have at most 2 ones, when you have at most 2 ones. Okay, when you have at most 2 ones. So from total you remove when you have exactly 0 1, when you have exactly 1 1, or when you have exactly 2 1. Is this clear? So from total you remove at most 2 ones. You remove at most 2 ones.